Hey televisions, back with me again, Ajika Utama Putrada. I am a lecturer for parallel and distributed systems. This is the ninth meeting for parallel programming model. In the fifth video, we are going to discuss about problem decomposition. So where are we now? Let's do a little recap if you forgot. So we are talking about parallel programming models, and we have discussed the programming models based on memory. If you want to discuss about based on the memory, usually we also call it based on its interaction. So there are two types of interactions. There is a shared memory interaction and there is a distributed memory interaction. In the shared memory interaction, we have learned that the problem is a race condition and the program that is used is OpenMP. And in the opposite of shared memory is the distributed memory, and the problem in distributed memory is communication, and the programming that is used is MPI. Now we are going to talk about a different point of view, which is not based on the memory of the program or the memory of the architecture, but the problem decomposition. So what is problem decomposition? Let's discuss about this. So what is problem decomposition? Problem decomposition is how we create a program on how we want to solve how we want to solve our problem. So we have a problem, and based on that problem, how do we want to solve it, and that becomes our parallel programming model or paradigm. So an example for problem decomposition here is here, for example, we have a program. Where is the program? This is the program to log x. So it receives x and it returns to log x. And here we have a so this is a program here. And here we have the x's, which are many. So to log 1, to log 2, to log 4, to log 8, to log 16. So this is the data. So there are multi-data, but only one program. So how do you solve it? Usually we divide the data because we have, for example, we have 4 processors. This is done by processor 1. This is uh, done by processor 2, and the second line here is done by processor 3, and the last one here is done by processor 4. So if you do it with 4 different processors, the problem is solved more quickly. So here we have a single program, which is to log x, and we have multi-data. So this programming model is called SPMD. Or in Flynn taxonomy, which we have learned in the previous meeting, if you still remember, in Flynn taxonomy, you can call this SIMD, which is basically the same. SIMD is single instruction multi-data, SPMD is single program multi-data. So this is one way of problem decomposition. So you see the problem is 2 log x, which is one data but many one program but many data, so you use SPMD. So that is the end of our fifth video. In this fifth video, we have successfully discussed about data decomposition. In the sixth video, we will discuss about the opposite of SPMD, which is MPMD. Thank you for your attention.